Now in section 4.7, we're going to talk about what are called the inverse trigonometric functions. In particular, we're going to look at inverse sine, inverse cosine, and inverse tangent. There are inverse functions for the other three, but we don't see them quite as much. And I'll say that before we get into it, we should remind ourselves about what an inverse function is generally. So if we have some function f of x that is 1-to-1, that is, if we're going to look at the function graphically, we get one unique output for every input. It doesn't fail the horizontal line test, as it were. We have some other function f inverse, which is denoted with a -1 as an exponent of x, where we have that f at f inverse of x, if we compose in that direction, we get the same thing as if we take f inverse of f of x, we just get x. And if f of x equals y, then f inverse of y equals x. That is, the inverse is the function defined specifically to undo what f does. Now, this is a fairly abstract concept in and of itself. When we're talking about just any old function, it might not have a great deal of meaning. But when it comes to trig functions, this actually serves a particular purpose. It has a particular function, if you will. In this case, when we're looking at the inverse of a trig function, what we're doing is reversing the relationship that we define a trig function upon, where we always said that when we're talking about our trig functions, we're trying to get some information about a radius from a piece of information about an angle. For an inverse trig function, we're saying we know something about a radius, and now we need something about an angle. And the first one we're going to look at is inverse sine, where I'll say that there's a bit of notation that's popular with these that I particularly dislike, but I'll talk about that when we get there.